Hello, everyone, and welcome to the breakout session. Today, we're going to talk about a very interesting topic, how to scale agents in production with Agent Engine. First, let me just do a very brief introduction. My name is Huang Xia, and I have Zhan Li, who is going to join me today. We are both from the founding team of Agent Engine at Google Cloud AI. We would like to share with you the exciting features on Agent Engine and also the lessons, takeaways from our agent building experience over the past 2 or 3 years. So let's get started. I will cover what Agent Engine is, and Zhan will dive into the details for agent building with the Agent Engine. Before we talk about Agent Engine, let's first revisit the AI agent. The definition or shape of AI agents are still evolving. And at this time, the definition of AI agent is a system that can reason, plan, execute, and reason for the user. The most critical components are models, which is the brain of the AI agent, tools, which are used for performing actions or acquiring data, orchestration to plan, execute complex and multi-step plans, runtime to serve and manage the AI agents. Let's dive into a typical user journey that can illustrate the agent workflow at the right side of the diagram. First, a user sends a query which hits the APIs of the agents that deployed on the agent runtime. Agents plan, execute, and observe in the runtime and execute the complex plan. Then agents use tools to fetch data and perform actions. Agents maintain the state with memory. Agents use various models to reason. Eventually, agents return the response to the end user. Now let's take a look at the Agent Engine. Agent Engine provides a set of managed services for you to productionize your AI agents on Google Cloud. To be more specific, it provides a scalable and robust runtime for you to deploy, serve, and scale your agents. It has a dedicated context services to manage the context for your agents. Agent evaluation service to evaluate the quality of your agents, and other advanced tools such as Code Sandbox to execute the code produced by the agents safely and securely. Lastly, full observability for you to monitor the agents that are running on production. So as of today, Agent Engine supports various frameworks such as Agent Development Kit, LangChain, LangGraph, Llama Index, AG2, etc. You can use various tools such as MCP tools, API tools, and Google built-in tools through those supported frameworks. From high level, we don't want you to build the foundational infrastructure, but rather focus on building the intelligent logic for your agents. Next, let's take a look at how Agent Engine fits into the broader Google Cloud AI agent builder stack. We recommend developers to build and optimize agents with ADK, deploy, manage, and scale agents with Agent Engine. Use A2A for the agent-to-agent communication and coordination. Of course, use Gemini to power your AI agents. Agent Builder is a very powerful platform for you to build enterprise-grade AI agents and automatically evolve your agents with Google's continuous innovation. So I personally developed many agents, and I have seen many agents developed by others. I think at this time, it is safe to say 90% of the agents will never be able to go to production. And it is always fun to see the different stages for agent development. During the proof of concept, people with several lines of code with the agent framework connects the agent to a model and several tools. They quickly get excited. Oh, wow, my agent can book a flight. Yeah, this is pretty much very amazing, huh? But then when it comes to the reality check with more test data, people start to realize that, wow, the agent hallucinates. It forgets things. Tools are unreliable. And security is a concern. Things become frustrating very quickly. Finally, when I try to go to production, as the traffic ramps up, things can quickly catch fire. They hit unexpected usage, costs, and various security concerns. These are the problems Agent Engine is born to solve. Now, let's take a look at the minimal user journey to develop, deploy, and query an agent on Agent Engine. You start by defining your agent locally, conforming to the Agent Engine's protocol in the SDK. Once the agent is created and tested out locally, a single API call called agentengines.create will deploy your agent to the Google Cloud seamlessly. Once the agents are deployed, your agent is ready to take requests at scale. Agent Engine natively supports 3 types of cloud APIs: unary, streaming, and bidirectional streaming. You can use some or all of those depend on your use case. Agent Engine also provides APIs for you to manage the deployed agents. Let's put them together. So basically, you develop agents locally, deploy your agents on Agent Engine, use the dedicated cloud APIs to query your agent, and manage your agents with a management API. In practice, although you don't necessarily need to work with these low-level APIs because we have the pre-built templates to further simplify this experience. Next, Ran will walk you through the Agent Engine journey in details. Ran, it's all yours.
Thanks, Huang. Now that we understand what Agent Engine is and the problem it's solving, I want to take you through the actual journey of using it. We will explore the complete life cycle of an agent, how to develop, evaluate, deploy, and continuously observe it at scale. Let's zoom out to the full life cycle. Productionizing an agent is not a one-way street. It is a continuous cycle. It all starts with development, using an open source agent framework like Google ADK, LangChain, LangGraph, and use Agent Engine's building blocks like code execution sandbox, session service, memory bank, and example store. This code is then deployed on the Agent Engine runtime. You may deploy and manage a fleet-wide of agents for your enterprise. All of this can be automated via Terraform and CI/CD. As users interact with the front-end web server or the API, all the data flows into our observability stack, tracing, monitoring, and logging. And the data also flows into your data services, including your own data storage or Agent Engine managed session or memory data. This data then feeds the most critical loop, evaluation and quality hill climbing, where you will use the evaluation service and example store to continuously improve your agent. Now that we have the high-level picture, let's dive deeper into the first phase, develop. Getting started is as simple as a pip install. Agent Engine is part of the main Google Cloud AI Platform SDK. To make development even faster, we provide pre-built templates. Whether you're using our own agent development kit or the popular open source frameworks like LangChain, LangGraph, or Llama Index, you can initialize the production-ready agent just within a few lines of code. Agent Engine provides all these unified interfaces via the pre-built templates for you. This gives you a consistent experience while letting you to keep the customizability of your preferred agent framework. As you develop, it's crucial to keep some of the best practices in your mind. First, start with the progressive complexity. Always begin with a single agent and one tool. Master this core reasoning loop, ensuring your agent can use this tool and understand its output correctly before adding more things. Then progressively, you can switch to a single agent over multiple tools, and then multiple agent over a single tool, and eventually multiple agent over multiple tools. Scaling to the multi-agent system can exponentially increase the complexity from debugging one single agent logic to debugging the peer-to-peer interactions among a swarm of agents. Next, you should also think about evaluation from day one. Evaluation is not just the final QA step. It is a core part of your development workflow. So create a golden set of test queries with some known answers from day one and run these evaluations continuously. This automation is essential to prevent the breaking the existing functionalities when you add some new features. It can also tell you how much quality headroom you have to improve your agents in your important business use cases. The third point is that context is a key. Context is the most critical factor for performance. It's everything that the model can see. All the stuff in the context is directly accessible to the neural network. The quality and the relevance of this context window directly determine the agent reasoning quality. And there are many, many hard engineering lessons on how to manage this context efficiently, such as utilizing the KV caches to reduce latency, and how to compress this long context into shorter tokens to save your model cost without degrading your agent quality. Tool design is also critical. The large language model only knows your tools via their descriptions and argument schemas. Vague descriptions can cause hallucinations, so be very precise. A function name such as getAccountBalance with some clear parameters is a good example that an agent can reason about and use correctly. This is also why the open standards, such as the Model Context Protocol, are becoming very important, because they provide a structured way to ensure that these definitions are clear. And then you can also iterate these two definitions in your own MCP server. Two definitions are just as important as your system prompts. Next, it is also very important to design your human-in-the-loop. Some agent workflows require the confirmation for decision-making, verification, and general oversight. In these cases, you want to get a confirmation from a human before the agent takes actions. You need to design explicit off-ramps for human intervention. For example, require the user confirmation for some high-stake actions, like, are you really sure you want to delete this account? Human in the loop is your safety net for correctness and your user trust. Finally, you should also architect for disaster recovery. Your agent runtime, the code, must be stateless. All the state, like the chat history or user data, must be externalized in a durable service like agent engine session service or memory bank. This separation of compute and state is what enables the high availability and high success rates. A crashed agent instance can then be restored, load the state, and continue the execution. A key part of the development is managing the state. Agent Engine provides you the managed session service to store the chat history at the event level. It is a simple append-only storage. You create a session to get a new ID, append event to add the new user or agent interactions, and you list events to retrieve the history of a given session. This makes your agent stateless because the state is managed by this external session service. Sessions are the raw history. Memory is the next step, used for personalization and generalization. Our agent engine memory bank can automatically generate memories from your session history, extracting and consolidating the key information. The agent can then retrieve the memories from this bank for future sessions to provide a more personalized experience. We also support memory as a tool, allowing the agent to explicitly decide when to create a new memory. Another powerful feature for improving quality is example store. This service provides the dynamic future examples to guardrail the agent and improve the determinism. Instead of hard-coding the examples in your prompt, you can create examples in the store, and the agent can retrieve the most relevant ones at runtime based on your user query. As this table shows, using just 1 or 2 dynamic examples can dramatically improve the task success rate from 44% up to 83%. For complex reasoning and multi-step reasoning, an agent reliance on pure natural language can be very concerning. And large language models' generative output is very probabilistic, making it unsuitable for tasks that requires the deterministic execution. This is where the code execution becomes very critical. By generating and running the code in a secure sandbox, the agent can offload this complex logic. Code can provide you the unambiguous and precise logistics for tasks that are brittle or impossible for a large language model to reason directly. Agent Engine provides a secure code execution sandbox as a tool for you. The agent model can then generate code and run it in this stateful, isolated environment, get the result back, and continue its reasoning and next actions. Finally, during development, it is very important to choose the right API type for your agent. For short-bounded tasks, such as a simple lookup with a few seconds delay, use our Unary API. If you want your agent to feel faster, use the server-side streaming API. This enables you to show the progressive updates to users, like the agent's current reasoning steps or actions, rather than having the user to wait for the final answer. And for a truly continuous conversational-like experience with interruptions or clarifications, such as creating a tutor agent for teaching or creating a voice agent for customer support, bidirectional streaming API is your right choice. People also call it Live API. Okay, so we have developed our agent. Now we need to measure it. Let's talk about evaluation and quality. We offer robust metrics-based evaluation using Vertex Evaluation Service. You provide an evaluation dataset that includes the prompts and reference trajectories. Trajectories contains the ideal true calls and responses. We provide many pre-built agent eval metrics, and you can choose the metrics that you are interested about, such as trajectory exact match. Then, in our eval task, it runs your agent against this data set you provide and gives you a very detailed report on the failures, latencies, scores for each metric as in this evaluation results table. This is how you can systematically hill climb and improve your agent quality. Earlier, I mentioned that example store for development. It also has a full UI in the console for managing your examples. You can see all of your stored examples, filter them, and edit them directly. This makes it easy for both developers and non-developers to curate the few shot examples to guardrail your agent behavior. Now that we have developed and evaluated our agent, it's time to deploy and serve it to the real users. You can deploy from your open source framework code directly. We support deployments through multiple pathways. They are optimized for different personas and users. You can either securely bring your own Git repository, or you can bring your code as files directly, or you can use the pickle-based approach, which automatically serializes your Python object. All these methods let you to deploy your agent on the fully managed agent engine runtime using Terraform, UI, SDK, or API, whichever you want. If you want a quick start, You can also try our sample agents in Agent Garden. Agent Garden provides a rich library of 14 sample agents and 34 sample tools that you can use immediately. So as you can see here, it is as simple as finding a use case that interests you, such as the financial advisor agent. And then just by hitting this blue deploy button, with one click, you can get a fully functional agent running on our platform. It is a great way if you want to explore the capabilities or just jumpstart your project. When your agent is served on Agent Engine, you get a fully managed production-grade runtime. This means that it can scale down to 0 to save your cost, or scale up with your traffic automatically. It is built with all the enterprise security features you need, such as VPC-SC, CMAC, data residency, access transparency, and HIPAA compliance. This example diagram shows an agent securely interacting with the backend data sources like Spanner or BigQuery via the MCP server, co-locating with the agent inside the Agent Engine runtime. And this agent uses the Agent Engine session service, memory bank for data storage, and use sandbox for code execution. We also give you the full fine-grained runtime controls over your deployment. You can configure the exact CPU or memory, the minimal or maximal instance for scaling. You can tune the container concurrency, set up the environment variables, connect to your secret managers. You can also manage your agent access controls with your own service account. You can configure the encryption keys and the network requirements, such as PSCI and DNS peering. And as we discussed in this developer stage, the serving runtime natively supports all 3 types of APIs. Your front end can call the standard unary API, streaming API, or the bidirectional streaming API on the same deployed agent, giving you the full flexibility on how you want to build your agent experience. Agent Engine is also built for complex distributed multi-agent systems using our A2A protocol. You might have an agent on our runtime that needs to call another agent. With Agent Engine, we enable your deployed agents with native A2A protocol as a first-class citizen. You can easily run both agents and use the A2A protocol as a communication channel. Therefore, your agent, potentially built by different open source frameworks and by different engineering teams, can interoperate with each other inside your enterprise. The final and one of the most important piece of the production lifecycle is to observe your agent behavior. Agent Engine has deep native integration with Google Cloud Trace. Simply by enabling this tracing, when you define your agent, you get this incredibly detailed flame graph for every single query. You can see the full agent execution trace, drill down to each model invocation, and each tool call with a request and the response details, precise to the millisecond level. This is invaluable for debugging and finding the performance bottlenecks of your agents. Alongside of tracing, you also get the monitoring dashboard out of the box in Agent Engine UI. You can track all the performance metrics such as queries per second, request count, latency percentiles for each agent you deployed on Agent Engine. You can also monitor for the underlying resource consumptions, such as CPU and memory allocation, to ensure that your agent is scaled correctly. If you want log, no problem. Everything that your agent outputs, standard out, standard error, or system events, is automatically captured. Finding these logs in your Google Cloud Console is very simple. This gives you the immediate access to these raw, detailed logs you need for deep debugging, auditing, and compliance. So to bring everything together, let's quickly recap on this entire Agent Engine journey. We started by identifying the core challenge. the massive gap between an exciting proof of concept agent demo to a reliable, secure, and production-ready system. Agent Engine is our fully managed platform designed to bridge this exact gap. It provides you the complete end-to-end lifecycle for moving your agents from the toy demos into the production. It provides the complete set of modular managed services designed specifically to solve the unique challenges of AI agents. First, we give you a fully managed runtime. You can deploy your agents, whether they are built with our ADK or other open source frameworks, and let us to handle the infrastructure for you, scaling down to 0 or scaling up with the traffic automatically. For context management, you have the session service for immutable conversational history storage, and you have memory bank to automatically synthesize this history into retrievable long-term memories that can be used for personalized user experience. We help you to hill climb for a better quality. You can use the evaluation service to measure the performance against the golden data set. And you can use the example store to dynamically guardrail your agents with few-shot examples, which can dramatically increase the determinism of your agent. And you're never flying in blind. With the native integration to CloudTrace, monitoring, and logging, you can see the exact decision path for each query, model costs, tool usage, and latencies, all in real time. Finally, for agents that you need to perform the complex multi-step reasoning, our stateful code execution sandbox enables you to execute code safely in this isolated environment. So in short, Agent Engine provides you all these critical components you need to move beyond the demo and successfully build, deploy, manage, and scale your agents in the real world. We build Agent Engine because we know the reality of shipping AI products. Concepts are usually very fast, but the long-tail problems are usually very slow. The real progress doesn't just happen within these neat diagrams. It happens in the messy, detailed, chaotic, back-and-forth engineering battles. Agent Engine want to be your weapons in these battles. So lastly, we have many exciting news to be shared with you in the incoming month. So please stay tuned. You definitely don't want to miss it. That brings us to the end of this presentation. Thank you so much for your time. And also, please scan this QR code to complete the event questionnaire. Thank you.